Hello, everybody. Welcome to another episode of whatever this show's called. I haven't made a name up for it yet. Anyways, we're going through some programming problems here on codesignal.com, and right now we're going through this one called Common Character Count. So let's just jump right into it. I'm going to be using C++ to code that's what the language I'm most familiar with, for the most part. And let's see here. What's the problem? So the problem's called Common Character Count. Given two strings, find the number of common characters between them. So gives us an example here for AA, BBCC, and S2, ADCAA. The output should be common character count for the string 1. String 2 should be 3. So why is that? Because, let's see. What was it? It was AABCC. A, A, B, B, C, C. That's S1, S1, and then S2 equals ADCAA. ADCAA. The output should be 3. So between these, there's 3, what's it saying? It's 3 characters in common, or 3 characters that are the same. And how can we determine that? Well, basically saying that it looks like it's taking the character count. So it's saying, okay, there's 2 A's here, and then there's 2 A's that I can match it to. And then there's 2 B's, but there's no B's here in this area. And there's 1 C here that we can match. We can see that's 1, 2, 3 characters. That's why this has 3 common characters. Okay, so now what I'm trying to do right now is think of a data structure that's really going to help us with this. What are the characteristics here is that we're trying to basically count these characters that are in common. Whoops, let's see. There's 2 A's, and there's 1 C, right? So how would I go about solving this problem? I think I'm going to use a dictionary. Erase. In case you guys don't know what a dictionary is, basically a dictionary can be thought of as perhaps conceptually as 2 parallel arrays that with one of the arrays representing the key and then the other side representing the value. Just like if you were to go into a dictionary, and look up the word, fire, it could be like really hot thing. I don't know. I'm not very good at defining fire. But right, you have the key, which is the fire, and then you have the definition right here. This is why we use dictionaries, right? Because you match these words up to other data. And that can be boop, 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 boop. Fire. Okay, so let's make our arrays. I'm going to use red. Maybe you can even think of it as a table, since it kind of looks like a table. Boop. Boop, boop. Okay, so I think I'm going to have a dictionary, as it were, for each of these. Now let's consider some input, right? We have that first string, which was A, B, B, C, C. Now what I can do is say, okay, my dictionary is going to be 26 elements long. Um, Actually, dictionaries don't have a length. Okay, I'm sorry, I forget. The important part is that this is a good way to use, a good structure to use, and this is why. I can say, oh, A, B, C, D, and there's no E's, so we'll just save it this example. So when I go through, what I do in my program, after I set up my dictionary, I can have this as these can be the characters, and this can be the counts of the letters that we encounter in each string. So let's see. So how many? So we encounter an A, right? Let's cross off A, and then we will bump the A up one, and then we cross off A again, and we bump up A to 2. And then we cross off B again, or sorry, cross off B. So that goes to, I'm just going to cross these out, to 1. And then find a B again, cross that out, that goes up to 2. And we do the same thing for C, there's 2 C's. Right? Okay, so that's how we went through the first string. Now what was that second string? It was A, D, C, A, A. Alright. A, D, C, A, A. Okay, sorry my handwriting's so bad. I'll practice more as I do these videos. So what I'm going to do is, let's see. How will I know what it has in common? I could try, well, I was thinking, I was like, oh, I could subtract these letters. And then I would end up with -1 here. Maybe I don't want that. What I could do is have a second dictionary. This may not be, I'm not going for the most efficient here, guys, by the way. So I know there might be some programmers out there that are like, hey, this is really inefficient. There's a way better way. Well, I'm just making this up as I go. I didn't really think about this ahead of time. So let's make a second dictionary. And do the same thing. A, B, C. That's it. There's a D in this one. D. Okay, so let's go through the counts. We can just look at this and count the number of A's. There's 1, 2, 3 A's. In our program, we would increment each one as we encounter them. There's a D, and there's a C. So where does this get us? And there's 0. And it starts out as 0, so that helps us a little bit. I'm thinking that what we do is can I scroll on this or create a next page? Sorry, it's my first time using this software too, so yeah. Hey, this is nice. Um, so basically we compare these two numbers, these two letters together right here. We compare these numbers, right? Then we can say, what is the absolute value? Oh, sorry, not the absolute value. What am I thinking? I was thinking of something else. What is the um, what's less? What's less? Dict 1 is less than dict 2. Or how do I want to do this? Um, previous page. I want to pick this one because I know that what I'm trying to say is I know that there's two A's in common because there's two A's that we can share, right? So I'll pick the lesser of these two and say if it's yeah, oh yeah, I'll pick the min. The min. That's a min function. Okay, yeah, that's a built-in function that we can use. Um, so I want to say I want to take the min of dictionary 0 of A and dict 1 of A. Yeah. So in this case, if we look back, that's going to give us the minimum between these two is the 2 right here. And so that will give us equal to 2. Now if we were to replace this with, B's and C's, then we're going to get the minimum between these two is 0. 0. So it's A. Oh, come on. Boop, 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 boop. A is 2. B is 0. No, redo. Page back. C is going to be 1 and D is 0. So C is 1, D is 0, right? Because we're comparing these two. The B's, that we had the lesser of them, that was 0. The lesser of the C's is 1. And then the lesser of the D's is 0 here. So going back, C was 1, D is 0, right? And I'm going to say, okay, well, any of the ones that are greater than 0, let's add it to our output list, right? Which would be whatever it asks us for, whatever structure it's asking us to return. And in this case, it's asking us to return an int. Oh no, it's just asking us to count the number of characters. Then we'll go through. What am I doing? Maybe we'll go through as we're finding the min. If it's greater than, so we'll start with like a count. Equals to 0. And then every time we do this min function, like, oh, the A's, how many A's were there that were in common? Oh, there was 2 of them. Okay, so we'll take the min and then increment. So that turns to 2. And we'll go through. The B's were 0, so we don't have to do anything. The C's, oh, they were greater than 0. They have a common C. So then we'll increment with, or add the number of C's to our total count, which will make this turn into 3. So this is our answer. And as it turns out, that's the same as the same right here is 3. All right, so let's put the coding, my drawing pad aside and get to the coding part of this. So first I need to do is create my dictionaries. And I'll be honest, I already forgot how to do the dictionaries, so I'm going to look it up real fast. Is it called a map in C++? Yes. Collection of I don't need to be hashed, but we'll do a map. A collection of key value pairs sorted by keys. Keys are unique. Does that help us? Because are our keys unique? Yes, because our keys are the letters of the alphabet. I guess, assuming they're letters of the alphabet. But, so that should be fine. So I will use a map. That seems to be what I want. And looking through here, what do I need to insert? I need to insert a pair. Why did they make it so complicated? Okay, let's just get into it. So include map. Let's see. We'll say std map, and this is a parameterized type, so it's going to be char and an int, and we'll call this s1 map. Just in case you guys are confused, a map is what they call dictionaries in C++. And then there's an s2 map. So I have my maps. And then I'm going to write a loop for char c in s1 we're going to s1 map dot, I want to, oh, that's nice. At C plus plus. That's funny. Okay. So basically what I'm saying, what I want to do, I don't know if this is right. I mean, it could be a compiler error for all I know because I don't know, bad or something. But for each char named C that's inside of S1, which is one of our strings, I want to look up that character and increment it. Notice how we're not like going through and adding all the letters first, right? Because what if this hasn't letters? What if this is like ampersands and open curly braces and stuff? You know, doesn't just have to be letters of the alphabet. So we try to leave that abstracted out. And then assuming that works the same way for the other one, char c inside s2, s2 map dot at c plus plus. In fact, no, I won't confuse you. You could just You could do both. Some people are like, oh, well, if you put it in the beginning, it's more efficient. Well, it doesn't really matter. In this, you can do it in the front or do it in the back. But actually, can we even do an assignment there? We'll try it. I might have to use the plus equals operator, but maybe not. I don't know. Anyways, we did the loops, so we have our dictionaries loaded up. And now, what do we do? Our maps are of the equal length, or what do you want to call it? So I wonder if there's a way we can. Let's see. If it's not in S1, then it doesn't matter if we look it up in S2. Is that true? No, that's not true because it might be. So I'm struggling with this right now because I'm like, okay, I could be like, for each and I equals 0, is less than like S1 map dot. Um, oh, a string consisting of. Okay, so this helps us a little bit. A string consisting of lowercase English letters. Um, because right now I'm struggling with, well, how do I know? I don't want to mess it up because what if s1 dot map and if s1 map has like an underscore and s2 doesn't, then I'm like, okay, I'll count it just fine. But what if it's the opposite? What if s1 doesn't have an underscore and s2 does? But it doesn't matter. They've given us some more constraints. I hadn't read all of them. So a string consisting of lowercase English letters. So that means that these are going to be all lowercase English letters. That helps us. And a guarantee constraint that S1 is going to be between 1 and 15 characters long. And the same with S2. So how does that help us? We could go through at each letter of the alphabet and and put it on there. I mean the counts. Hmm. Okay, so right now I'm trying to find a good place or a good way to use this to help us. Finds element with specific key. Maybe this helps. Um, does merge do? That sounds interesting. No, that doesn't help us. count. Returns the number of elements with a key that compares to the equivalent of the specified argument, either 0, 1, or a 0. Since this container does not allow duplicates. Well, I don't want to do that. Let's see. Finds an element with a key equivalent to key. Don't want that either. Contains. Check if the container contains element with a specified key. Hmm. Um, Inserts an element or assigns the current to the current element. I didn't wonder if I didn't want to use this silly. Maybe I'll scrap the dictionary idea and do something similar where I just want to use an array. I could try that and see where that gets me. I really don't like where this is going. The dictionary thing. I'm not. The API is not very helpful. I mean, maybe I could compare each one. So right now, how do I find? I can't just step through the keys. At least I don't think I can. And then either way, I'd have to step through the other array again. Really, I just want to step through it once. Um, yeah. Okay, let's just do this then. Instead of maps, I'm going to use an array. std array. Yes, there is an std array. You can also use a normal array. I don't know what you want to call that. And it'll just be ints. These ints will hold our and if I remember right, the ints will hold the number of characters that we encounter. And if I'm right, the array has to start with, yeah, class T size, and it has to have a size. So how many? It's going to be 26, because we know that it's 26. And where's the constructor? Implicitly declared. Okay, doesn't really help us too much. I wanted to make sure I initialize the values, but hopefully it initializes to 0. If it doesn't, then we can fix it. I'm just going to assume they all these integers default to yeah. So we can still keep this for each character in char C in S1. We can say, okay, well, I want to get that count, you know, R at C, but this isn't going to help because what if C, well, no, it's guaranteed to be at that array, or it's guaranteed to be a letter in the English or in the English alphabet. So, you know, 0 through 25 is what we want to go, and there's 26 letters. Okay, so we need to make sure that we need to find the ASCII code value, because a, lowercase a, does not match to a, does not match to 0, right? There's a lot of characters that come before a and come after a. So let's just look at this ASCII chart. And we can see here that a, lowercase a, I don't know if you can see that, it's kind of small, corresponds to 97. So that means when I'm at a, I want to subtract 97 to get to 0. I want it to be my 0th offset, so I'm going to go minus, and I'll do this, char ASCII offset equals 97. So now I can go C minus ASCII offset plus plus. And I can do the same thing down here, too. ASCII. Okay, so now I say, okay, for int I equals 0, I is less than, they're the same length. S1 and S2 are the same length, so we're just going to use either one, and it will get us what we want. S1R dot, it's always size or length? Which one is it? Size dot size plus I. Okie doke. So now I'm just going to go through std min. Yeah? Yeah. So I go through std min. I need to figure out which header it's in for C++, so it's defined in header algorithm. And so I will include, sorry, I need to put it in alphabetical order because I'm kind of a stickler about that. Include algorithm. And then I can say int, I don't have a good variable name for that, and n equals std min I'll call it common char count. And I'll make another integer up here called int total common char count equals 0 of S1 R at I, S2 R at I. Okay. And then we will just simply add count, char count plus equals okay. So that's basically saying, add whatever you get from that min function, the one we talked about over here, the min function, not dictionaries anymore, they're arrays. But whatever you get, I want you to add it to the total count. And then, of course, we have to return our result. which will be the total common char count. And let's see if it passes our tests. See if it compiles. Ah, it didn't freaking pass. I think I know why. This is because our array is filled with junk, as I feared. So we will initialize it with a for loop. For int I inside s1, no, for int I equals 0, I less than s1 r dot size plus I. And then, let's see, s1 r. I'll just go use this operator equals, or sorry, of I equals 0. And we'll do the same thing for s2. See if this helps us. Because, what happened? There it is. Okay. Oh, I think it's because I tried to save it. Okay, run tests. 5 out of 5 sample tests pass. Click submit to run the full test suite and save your solution. Okay. So what I'm going to do first is save this off somewhere. No, I don't have to. It'll save it for me. And I will hit submit and see what happens. Yeah! It only took me an hour, it looked like. Okay. Anyways, we solved the problem of common character count. Thanks for watching this video. It was a little rough. Some rough patches for there while I was trying to figure stuff out, but that's how it goes with these problems sometimes. Sometimes you work on something, you think you have a solution, it doesn't work out, and then you just have to change your method until you get it right. So, anyways, thanks for joining me. See you next time.